So the seed square, which we are to assume has an area of 1 that was given in the question in the packet, I forgot to reprint it here, but the seed square is supposed to have area 1, and so the area of the seed is 1, and then the area at step 1, well, it looks like I broke this seed into 9 equal pieces, and I threw one of them away. So I have 8/9 of my original area. 8/9 of 1 is 8/9. And then step 2, I took each of my subsquares, each of my 9 subsquares from step 1. So for example, I took this subsquare and broke it into 9 smaller squares in the next step. Okay, so this became this. And I broke that into 9 squares, and I kept 8 of them. And I did that for every single one of these squares that remained from step 1. I kept 8 of 9 of them. So for step 2, I could try to count them all up. I could say, well, step 2 I have 1, 2, 3, 4, 5, 6, 7, 8, 9 down, and 9 across, so I have a total of 81 squares. And how many of them are shaded? Well, let's see, I've got 9, 10, 11, 12, 13, 14, 15. 15 plus 9 more is 24. 27, 30. 31, 32, 33, 34. 37, 40. 49, 50. 51, 52, 53, 54, 55, and 55 plus the last 9 is 64. So I have 64 shaded out of 81 total. I also could have figured that I did that based on how I created this second step. By keeping 8/9 of every square from step 1, I could take 8/9 of my previous step. So this way I could do 8/9 times the amount I had at the previous step, which is 8/9, and that gives me 64 over 81. So for step 3, I could try counting, although it would be tedious. Or I could say, well, I did the same thing in this step as I did in the previous step. For each tiny square in step 2, for this little square here, I broke it into 9 pieces and kept 8 of them. So I'm going to take 8/9 of the area that I had in the previous step. So I would take the area I had in the previous step, 64 over 81, multiply by 8/9. And let's see, 64 times 8 is 512. And 81 times 9 is 729. And step 4, I don't even have a picture of, so I can't even try to count it. So I'm just going to have to go with my times 8/9 method here. So if I do my previous area times 8/9, I get 4,096 over 6,561. So if I want the area of the carpet at step n, I could give a recursive definition where I would say, well, it's equal to the area from the previous step, a sub n minus 1 times 8/9. Or I could give an explicit formula where I could say the area at step n is equal to the area from my seed, which was 1, and then I multiply by 8/9 over and over again n times. So what is the area of the carpet approaching as the number of steps approaches infinity? Well, if I keep throwing stuff away, I keep throwing away a ninth of my carpet at every step, then I'm going to start approaching nothing. This is going to be a pretty threadbare carpet if I keep throwing a ninth of it away. So as the number of steps approaches infinity, the area is approaching 0.